a good job of it.
Yeah, there's TeamSpeak, there's a whole bunch of others that are out there. Now,
Right.
I was going to ask you to address its quantity, where it falls. Does it fall into peer-to-peer, or does it fall somewhere else?
So this graph is August, and Skype wasn't to be found. I have one with Skype, but it's still very, very small. And at the same time, we're measuring this on some European networks, and it's doubling every 10 days.
You may want to try also TeamSpeak. Because I have a TeamSpeak. I have a TeamSpeak server for me and my buddies because we're national. That way we don't use a telephone.
So TeamSpeak, I think, is not a pure peer-to-peer.
It's not. No, it's not pure peer-to-peer.
Right. Right. So there's a bunch of those that exist, and it's easier to track. But the trick with Skype is it's completely peer-to-peer. So there's no server you can look for or monitor or bring a court order to shut down.
Right.
You can ping anybody on the peer-to-peer network and create a direct connection and have a conversation with. And it's not even illegal. There's a lot of copyright discussion over content being swapped.
Well, what about MSN? Is MSN, when you start talking to somebody on MSN, is that going through their server or you get? Okay.
So anyway, the deal is this. Back to the earlier question. Shutting down peer-to-peer is not something ISPs are going to do. It's not smart.
No, there are intelligent ways of handling it.
Yeah, and if you handle it intelligently, what happens is, since peer-to-peer is not interactive, and the usage pattern is you got 20 of those downloads going on in the background, it's become a background application. And from the ISP perspective, it is a nightmare because whenever you build a network, you never plan it or build it for the worst case scenario. You build it for the average case. And you say, even telephony network, you don't assume that everybody in Mountain View will pick up the phone at once and try to dial. And by the way, if it happens, a lot of those will have a busy count because the network can't support.
That's what happens with an earthquake.
Right.
Everybody calls up. Did you feel that?
And
yes, I did. Shut up.
You look at peer-to-peer, since it runs in the background, people leave their computers 24 hours a day, 7 days a week, connected to a broadband connection. This thing will suck whatever capacity you make available. However, at the same time, those users, like all the other users in the foreground, try to do something else. So they try to browse, they try to play a game, they try to download a video, and they get a really bad experience because the whole network is congested. So what we found out with a lot of those carriers is if you tone it down somewhat, everybody's happier, including the P2P users. So I think this is back to, if you manage this intelligently, everybody's happier. P2P users are happier.
So you recognize that it's a P2P, and you just say, okay, we're going to cap you at this much per set, but you can do that per session, right?
Per session or an aggregate level, and I think I have a graph or two that shows this. But what most carriers want to do initially is this: what is our network up to? And by the way, there's some subtleties because I think the light green, it says P2P on net. You look at P2P. And they typically say that there's two sides to P2P. One is you download stuff, but since you're part of the peer-to-peer network, stuff gets uploaded from your computer. That's the game. From your point of view as a user, you don't really care about that stuff that gets uploaded. You want to know that the stuff you're downloading gets in. So if you control the uplink more aggressively than the downlink, from your user's perspective, they don't care. It's pure gain, except for on-net, which means two users on your network. So you can say those I police less aggressively because they're both my users. So there's a lot of subtleties here. This is a Japanese example, and I think light green is white, and you can barely see it in this resolution.
Right.
But most of this dark gray is winning. And here it's and this is a gigabit link. So you look at almost at the right-hand corner,
all the way up.
a full gigabit connection completely consumed by So that's scary. The other stuff you see is some browsing. You see small amounts of interactive applications because when at that level of congestion, people try it, it doesn't work, they'll try it again.
But it could be that there's congestion and then there's back off and then there's more people getting on and they're still sharing the link more and more.
Well, back off and all those mechanisms for traffic control work, but they don't work if you're trying to run more traffic than the link can carry.
Well, I thought they should all see, if they're TCP, they all see congestion, and then they all back off.
Right,
How is it
but
that
backing
TCP
off,
and he doesn't
right,
care?
backing off helps you if this congestion is a peak
Transient.
and transient, and it goes away. But if this is steady state, then you'll back off, you'll come back in.
Very good.
It's going to be constantly back, because this, as much capacity as you have, teenagers will start enough file downloads to eat it all up. And by the way, if you deploy more capacity, those teenagers will eat more of it.
It's like food. More you put in the refrigerator, the more you eat.
So it seems like the big concern now is bandwidth. But if you look at like voice over IP, it's been said that in a data network, voice is free because you use so little bandwidth. But now that Curious have this capability, they can say, hey, we're losing revenue due to voice over IP. Let's regulate that. Let's charge for very little bandwidth.
Yeah, voice rights free, not when you're at that level where your link is completely congested. At that point, if you don't measure it, you don't manage it, then voice gets scrambled with the rest of it. If you look at this again, transport versus what we call service control. How transport deals with congestion beyond the mechanisms built into the protocols is things like random early discard. So the router is hit with more packets than it can handle. It would look at the lowest level of priority if those packets are marked and say, let's start randomly dropping packets which are the least important. However, in an application world, at the end of the day, the network is carrying application traffic. The result could be that you randomly drop packets from a lot of different sessions. It's equal misery, but what you'd really want to do is to say, here are the sessions in their entirety which I'd like to preserve because they're important. And here are sessions that I either don't care about, or maybe when congestion hits, I want to redirect them to a web page that says, cannot carry this request right now. This is the equivalent of interrupting a local visit, where you try to make a call and you use a busy tone, and it's actually the local switch. The guy you're trying to call is not busy at all.
Yeah.
But the local switch is busy. You'd rather have a local busy to say, I can't support this video session right now, try again in a few minutes, than start it. The user gets a really bad experience and never tries it again.
One quick question. A voice over IP call takes a few kilobytes a second, which is very little bandwidth compared to video on demand or
Right.
communication. Do you see carriers actually regulating voice over IP calls, that type of traffic, because they're losing revenue to their off telecom?
Yeah, so there's a technical answer and there's a
Philosophical.
Business.
And then there's one more layer to it which we are not even discussing. It is the supply versus demand.
Right.
And who wants to pay, and number of competitors. Few competitors is good for the competitors. Too many competitors good for the customer. There's a lot of new concepts here we have to look at, not just the traffic. This is
Right.
just the bits and bytes part of it.
So from just briefly to answer it, from a technology standpoint, yes, all the carriers that we're working with, one of the first things they want to do is to say, we want to have control over voice over IP traffic. Now that could be positive or negative control. But some of it is they want to say, if there's a carrier, this advantage, there's somebody who wants to run voice over IP as a service on my network, then I want a piece of the action. Because otherwise, the carrier is just a commodity broker.
Even if he transits through this network, if it
Yeah.
doesn't, if it originated inside or destined inside,
Right.
then he doesn't
You look
care.
like you look at a large incumbent, and they have a voice business, as you mentioned, and they have some other businesses. And they're saying, if people write voice over IP on our network and create a high margin business on it, all we get out of it as a transport carrier is nothing, basically.
So
Because,
these costs, that's it.
so it's both going to kill our voice business, and it's going to make somebody else rich, and we get nothing, and we are the ones that put the network together. That doesn't make sense.
Yeah.
They're not going to block it either. What they are going to do is to say, anything that writes on our network is best effort. If you want to run a voice business, we can make it
Sign a contract.
consistently good, but you'll have to pay some premium for it, and then everybody's happy.
Yeah. But if it's just the company which is only providing the transit from one end to another, just to transport, they probably would start charging in the settlement side of the whole thing rather than billing. Billing is to the customer.
Right.
Settlement is between the network providers. They say, oh, look, you're making more money, you're controlling so much more. Let me monitor your traffic now.
Right. There's three entities. There's
Yeah.
the end user who consumes the service.
Yeah.
There's the service provider who provides the service, the
Yeah.
voice over IP service, and there's
Yeah.
the network provider who, unless they get in the game, they just get rate.
Exactly. And there are
So
multiple
they're-
levels there also.
Right, and they're trying to get in the game and say, we'll sell you better bandwidth, so to speak, voice over IP bandwidth for some premium. You can then sell this to your users.
Yes.
Or,
It's already
I
there.
can't-
Yeah,
Can't
there are a
believe
lot
we
of-
need to move along.
yeah.
Well, no, you mentioned dropping packets at random. When you're overloaded, isn't that going to make things worse because the nodes are going to want resends, retries?
Often, especially with TCP, you drop the wrong packets,
Yeah.
and the window gets retransmitted. You generate more traffic rather than less traffic.
Yeah, it creates data spillage.
Right.
Yeah.
But if you're a layer 2 to 4 device, that's the best you can do. There's more packets coming at you than you can handle. You got to drop something. So the theory is, if the packets are marked with priority, I'll drop the lowest priority packets. If you happen to drop an ACK, it could be unfortunate.
30% of your traffic.
If you do have the application level perspective, by the way, you've got a much better chance of dropping the right packets or not dropping the wrong packets. Yeah.
There's a ton of great papers on this. They were all written 10 years ago. You should read.
Right.
This is all
Some more
been-
examples. This
that's
is
been solved.
a cable network. You can see CMTS, which is the aggregation. It's a fairly small access point. Over 7 days, carried 25 terabytes of peer-to-peer traffic. Terabytes, which is just mind-boggling. And you look at all the rest of the traffic, and it gets dwarfed. Browsing, FTP. This is Skype, by the way. Still small, but I expect it will grow. It will not be as big as this because, as you said, voice traffic doesn't require that much capacity. But in terms of numbers of sessions, it's
But
gonna
it
be,
wants high priority, so the timing stays.
Right, waiting to see that.
yeah, it could be a tool that is used by carriers to say, I can make Skype good, and I want something out of it, or I can make Skype bad, knock itself out.
What's going to happen when we go from NTSC to high def? As being able to transfer files, they're going to be, if they're not compressed, they're going to be, you think 1.5 gig is big, you're going to
Right.
be looking at what, 40, 50 gig for a single file?
Absolutely, and it's like people wondered what we would do with more than 20 megabytes of a hard disk on the PC, right? We've been through that, so people don't ask why do you need all that capacity, but you've got to have some reason to deploy more capacity. If you're getting nothing out of it, nobody's able to.
So I'm saying we're going to be stepping up as high def actually gets able to be.
As I think the home gateway and the set-top box converge, which I think will happen. And then that will be your Wi-Fi, probably connectivity into the home, into your stereo, into your TiVo, and download things and play them. Yeah.
I was curious, what seeing all of these charts, what is the size of the thing you're measuring? Is this one company? Is it one country? Is it one somewhere?
It's one location on somebody's network.
Somebody, is this a big somebody, a little? I mean, I'm trying to get a sense of the space
No,
you're measuring.
big. We're almost solely focused on first-tier carriers.
Okay, so it's a typical AT&T.
Yeah, somebody